always, sometimes, never. This time we want to decide whether or not it's always, sometimes, or never the case that a vector minus itself is 0. And you may want to say, well, this is pretty obvious, but let's prove this formally so that we have an opportunity to get used to notation and proof styles. So we'll start our proof with letting x be an arbitrary vector. That means it has no special properties. And we're going to look at x minus x and show that it gives us the 0 vector. Now, you may recall, at least I hope you recall, from the lecture video and notes that this subtraction is actually adding -1, a scaling of the vector x. So this is equivalent or equal to x plus -1 times x, just by the definition of what that subtraction actually means. And also, scalar multiplication is found by multiplying each component of the vector by -1. Before we can do that, though, maybe we should expose the components. So let's use notation to actually write out what we mean by the vector x. It's a vector of size n, so we write it as a vector containing components chi0, chi1, and so forth, out to chi n minus 1, where these are just real number values. And we want to then add to it -1 times that same vector, the vector chi0, chi1, and so forth, chi n minus 1. Now, scalar multiplication is done component-wise. We will take our vector x and add to it -1 times that vector. To determine this scalar multiplication, we take each of the components of x and multiply them by -1, resulting in -1 times chi0 is negative chi0. -1 times chi1 is negative chi1, and so forth, negative chi n minus 1. Now, we want to perform vector addition. And by the definition of how to do this, the result is going to be a vector of size n with components. Well, the first component will be chi0 plus a negative chi0. We just add component-wise. The second component will be chi1 plus a negative chi1. And the last component will be chi n minus 1 plus a negative chi n minus 1. But now each one of these components is found by real number addition. And any real number plus its additive inverse is always 0. So chi0 plus negative chi0 is 0, chi1 plus negative chi1 is 0, and so forth. We end up with the 0 vector. So, a vector whose every component is 0 is that 0 vector. And so it is always the case that x minus x is 0. Makes sense.